Okay, so today we're looking at a probability distribution. This table lists all possible outcomes when two tetrahedral four-sided dice are rolled. So the first question says, make a probability distribution table for the difference of the numbers on the two dice, first minus second, and verify that your distribution is indeed a probability distribution. So what I actually did here, okay, so what are the different outcomes we could have? First minus second dice. So we could have the first die minus the second die could be negative. So if we look here, our first die being 1 and our second die being 4, the highest we could have is -3. -2, -1, 0, 1, 2, and 3. So if we look at this problem here, we have, how many -3s do we have? The first die minus the second die being -3, there's only one of those, so 1 out of 16. The first die minus the second die being -2, we have 1, 2, we have 2 of those, so 2 out of 16. The first die minus the second die being -1, we have 1, 2, 3 of those, so 3 out of 16. The zeros are going to be right here on the diagonal, 1 minus 1, 2 minus 2, so there's 4 of those. And then the first die minus the second die being +1 is going to be 1, 2, 3 of those, 3 out of 16. Being +2, let's see, is 1, 2 of those. Being +3 is 1 of those. So then it says, describe the shape of the distribution. This shape is normally distributed because if you take a look here, you're going to have 1, 2, 3, -3, -2, -1, 0, 1, 2, 3. There's 1 of these, 2 of these, 3 of these, 4 of these, sorry. 4 of those, 3 of those, 2 of those, and 1 of those. So you'll see that it's centered right around the 0. And then it goes down by 1 on either side of the 0. Okay, then what are the expected value and the standard deviation? So if I look here at my notes to find the expected value from a probability distribution, we take our x multiplied by our probability and then we add all those together. So we have -3 times 1 over 16 plus -2 times 2 over 16 plus -1 times 3 over 16 plus 0 times 4 over 16 plus +1 times 3 over 16 plus +2 times 2 over 16 plus +3 times 1 over 16. And it doesn't say anything in here about, absolute value or anything. So we have then -3. When we multiply times a fraction, we multiply the top. So think about this as -3 over 1. So -3 over 16 plus -4 over 16 plus -3 over 16 plus 0 plus +3 over 16 plus +4 over 16 plus +3 over 16. So you'll notice here we've got a -3 over 16 and a +3, a -4 and a +4, a -3 and a +3. So when you add all these up, you would get 0. So our mean is 0. Okay, then let's see, the standard deviation. The formula for standard deviation is you take your number minus your mean, square it, and you multiply that times the probability. So what I'm going to do at this point is I'm going to switch over to my calculator because that seems like a lot. So I'm going to go into Stat and Edit, and I'm going to make my lists into a two-way table. So I'm going to have -3, -2, -3, -2, -1, 0, 1, 2, 3. Okay, and then I'm going to go over to my list, and this is going to be 1/16. And it will convert it to a decimal for me, which is nice. 2/16, 3/16, 4/16, 3/16, 2/16, and 1/16. Okay, so now remember, you can do one variable statistics with your two lists. So my list of possible values is L1. My frequency is L2. So again, if you had this, you would do one variable statistics, start your parentheses, L1, comma, L2, and then you would go to calculate. So you see here that your mean is 0, just like we found, and our standard deviation is 1.58. Okay, then let's see here what D says. D says, what if you roll, oh, you know what? I should leave that up there. If you roll a pair of tetrahedral dice, what is the probability that the difference is greater than 1? Okay, so let me erase my work on the mean. So we're looking for a difference greater than 1. So where is that in the table? And it says greater than, it doesn't say equal to, it says greater than. So that's just these possibilities here. So that's 3/16 would be your probability of getting a difference greater than 1.